Okay, so welcome to question 3 on the 2023 graphics paper. This question is actually across 2 pages here, so I'll do first page here. So, shown below is a 3D model for a coffee machine. Also shown is an enlarged view of the control panel for the coffee machine. So we've got our on, off, hot, probably our double shot espresso and our espresso shot. The outline of the control panel is below. So here's A, B, so A, B, that's our control panel. Complete the drawing of the control panel by dividing the line AB into 5 equal parts. So we want to divide this line up into 5 equal parts. So to divide a line into equal parts, we draw a line from one end at any angle. Doesn't matter. Okay, and I'm going to get a compass and I'm going to set it to any distance. And we're going to step off 5 times because it's 5 equal parts. So it's 1, step down the line, 2, step down the line, 3, 4, and 5. Okay, now always number your lines, just to make sure we're doing the correct amount of divisions. 4, 5, great. So what we'll do now is I'm going to join point 5 to point B. Okay, so that's the important line that I need, because every line now will be parallel to it. So using sliding set squares, slide back to 4, 3, and 1. Okay, so I've divided line AB into 5 equal parts, but we want to draw our control panel. So let's draw a vertical line, my on, my off, sorry, on, cold, hot, a double shot on my espresso. Okay, so that's the control panel. Then finally, color or shade. So I'm just going to allow and do some of the similar colors here. So light coloring. On. Okay, hot. For that. 2. Got our double shot espresso. A little bit heavier for espresso. Okay, so that's question A completed. Shown on the left below is the plan for the drip tray. So we've got the drip tray there. Design of the drip tray is based on a parabola AOB. So AOB, A to O to B, with vertex O, so O is the turning point there. Complete the drawing on the, of the drip tray in the given rectangle ABCD. So we want to fit our parabola into this space. So first off, I'm going to see, can I make life easy for myself, and are these measurements equal? So that's exactly 40 to the halfway mark. So I'm actually going to divide this up into 4 equal parts. 2, 3, 4. And then I can do the same on the opposite side, but I'll leave it for now. And then this way, this is 60. So yeah, I can actually, I don't have to use my construction for dividing a line into equal parts. So I can divide 60 into 4 and it's 15. So 15 15, 15. Okay. All right, so these lines here, we're going to run vertically, parallel to our axis. Okay, so that's 1, 2, 3, and then here we're going to join those all back to the vertex. That's 1, 2, 3. So 1 and 1 match up, 2 and 2, 3 and 3. So that's going to give me my curve. I could repeat all that same construction on this side, but just to show off a little bit, I'm going to do axial symmetry. Your call, you'll get the marks regardless. So point of my compass on the axis, set it to the distance to that first point, and swing an arc. Same here, set it to point 2, swing an arc. And then finally to point 3, swing an arc. So we've got all our points there, and we can draw our freehand curve. Okay, and then just to finish it off, I'll draw that line from A and B. Okay, and complete the drawing. Yeah, so we've got our rectangle, or we've got our parabola drawn there. Okay, so that's question B completed. Part C then, shown across as a box used to package the pods for the coffee machine. So we've got our box here for packaging it. The elevation and end view of an incomplete surface development of a similar box is shown. So our elevation and our end view and partially completed surface development. This box is based on a square-based prism and has the lid removed. So the base there, if we were to look down on top and see a plan of it, this base inside there is square. And it's got the top taken off it, and you can see that's been sliced off. A 3D graphic of this box is also shown. So there's a 3D graphic. Complete the surface development. So first off, we'll deal with that front surface which has the circle on it. So it's given that to us. So let's find that circle by, see there, joining the diagonals to find the center. All right, and the radius of that circle then is given to us in the elevation. Okay, so that's my elevation. Next, folding out to the side, we have this side here. Okay, so they've given us the fold line, they've given us the angle there, and they've given us the distance stepped off. So that one's already done for us. So now we're looking at the back. So the back is going to be at the same distance because it's a square-based pyramid. So same distance, same distance, same distance, all the way around for each one of these sides. So we get the compass, set it to that length, and you can see there it's the same length and same length again. And while I'm here, I'm just going to repeat that because the last side will be the same also. So we've got our division there. Okay, the height has been given to us for the back, so just need to extend that on. Okay, then it slopes back again. So if you want to take the height from here, step it off, you can, or we can just project that across. So that's that other side. I'll draw a side there. And we've got some fold lines. Okay, now what's missing is that square base. So square base, I can do it at any one of these sides, but I'm just going to do it here. Doesn't matter which one we do that. And make sure we get that length. Step it off. Step it off. So now we can draw the outline. That square. Easily heavy line there and a heavy line there. I'm going to have a full line there, and finally our outline of our square. Okay, so that's the surface development of the copy pods packaging. Okay, now turn the page and we're on to part D of question 3. So the image shows the design for a similar coffee machine. Draw the elevation looking in the direction of arrow A. The plan, so we're going to have the elevation. We're going to have the plan directly underneath it. And they want an end view looking in from B, so looking from this side. Looking from this side, so we're going to have an end view over there. And then in the elevation, color or shade a surface which is a true shade. Okay, so we'll deal with that after. So we need to come down far enough so that we can fit this in the page. So the overall height, we've got 45 and 30 and 25. So that's 100. So I'm going to come down a little bit more than that. I'm going to come down 120. I'll draw my XY line. Okay. So elevation looking from A. For elevations, I always have the height and I have the length, the shape. So let's mark off the lengths there that we can see. Total length is 110. Okay, so that's the total length. That's broken down into 25, 50, and 35. So 25 plus 50 is 75, and that's my 35 left. Is there any other length that I need? There isn't. So I can then project that for my plan view and elevation, because my plan contains lengths also. Okay, plan is length and width. Okay, so we'll get to that in a moment. My height then, so the overall height we said is 100. We'll just double check that. It's 30, yeah. So I'm going to mark off 45 and 30. 45. 30 is 75. 25 above that, so that brings us to 100 now. Okay, and I'll project those sides across, and I'll extend them further than I need because I'll use them for the end elevation as well, because end elevations we use height and width. Okay, and is there any other heights then that I need? Yes, 10 and 10. Yeah, 10 and 10 is there. So mark off my 10 and 10. And I'll project them across also. That's all my heights and all my lengths accounted for. So let's draw what we can see when we're looking from A. So I've got that front edge of 10 and back here. So front edge of A, then back 25 goes up to the height of 20, so just 10 plus 10. And we're going to have an outline then this L kind of shape, or reverse L. So that's coming across and up to here. That L is actually just right there. which is an L shape. Then we've got the sloping surface, which is 30 in height. Okay, goes to there. And then we've got the outline of this semi-cylinder, okay, which is 9 with 25, so that's going to be this space. Okay, so that's my elevation. My plan view then is going to be directly underneath it. The elevation done. Plan view is directly underneath it. Typically we come down with 10 or 15 mil between elevation and plan. Okay, so I have my length already marked in. What I need is width. Okay, so looking here from B, we've got the overall width of the shape is 80. So let's mark off that 80. Okay, and that can be broken down further into 15, 50, and 15. So 15. Okay, so those are the lengths, or the width that I need. So let's draw in the outline of that. So at the back, I have solid out and down there. I'm going to have an edge running down as far as that 25 mark. Same on the opposite side. Front, small surface there, and then sloping surfaces. Okay, so that's the outline of the base. We have this edge running across, so that's an edge for the sloping surface. We have our outline there of our cylinder, which is in line with the, in line with the 25, so that's going to be solid all the way back to there, all the way back to there. And finally, we've got these flat, the L that we talked about, that's running here directly up. We've got this sloping back joining the two, so that's going to be the front and the back. Okay, so that's our elevation, or sorry, our plan, and finally we want our end elevation. So rather than having to measure all those widths again, I can project back at 45 degrees. So bring those widths back, and we'll project them up because we've used them in a moment. Okay, I'm going to start with the cylinder at the top, okay, which is radius 25. So that's fitting into that space 50, so it's fitting here. So I'm going to measure across my 25 to the center and set my radius to 25. There we have the cylinder, or the semi-cylinder. Okay, and that's an edge then across the base of it. So that's what we see there. Then we have our sloping surfaces, so sloping back to there, there. We have our flat part coming down to the side, so flat down to there, and there. We have this rectangle, which is at the front. It's a height of 10 and a width of 50. So that will be there. Okay, and they slope back to that height of 25 on the edge, so or height of 20 on the edge, so back to there. There. We have this edge then going around. Okay, and finally we have this base that we need to show as a heavy edge. Okay, so I think that is everything we need. Our elevation plan. Oh, there's something forgetting from our plan actually, yeah. So our plan view, we got this edge running along here. So when we look down on top, there's technically an edge running on here as well. Okay, so there's an edge running inside there, so we need to show that as a hidden detail. Okay, I think that is everything that we need. Great, so now we have our part 3 done, so our orthographic views. Then in the elevation, color or shade a surface which is a true shape. So true shape is a surface that we're looking perpendicularly to, looking straight at. Okay, so if I'm in here looking at A, right, let's go through the surfaces. So this one is sloping away from me, so it's not that. This is a curved surface, so it won't be a true shape. This is also sloping away from me, and here, that surface there, that is going to be a surface that we're looking perpendicular to. Okay, we're looking straight at it, and the reason I know we're looking straight at it in elevation is it appears as an edge here in plan. Okay, and I'll actually highlight that as well for you. So let me just shade that very quickly. Okay, so that's it. And then here it is an edge view in plan. Alright, we don't need to highlight this, but just that I would. And then here it is as an edge view in the end elevation. Okay, so that's our true shape. Okay, so that's all of question 3 there, quite a bit in it across the 2 pages.